Dragon version 2. Although, it'd be nice to go inside. But for that, we will need a comically fast set of stairs.
So, I mean, I think we're in somewhat of an ignominious situation here where, I mean, it's not merely the fact that Russia is taunting the United States for lack of manned access to space, but they're also massively overcharging. And I think it's gone even above $70 million. I think it's sort of $76 million a seat that the Russians are charging. The quote that we've provided, NASA, would allow the cost per astronaut to be potentially less than $20 million. So it would, and that assumes a low flight rate. So in a high flight rate, it could potentially get to single-digit millions.
My dream of space is that humanity becomes a multi-planet species, that we have a self-sustaining civilization on Mars and perhaps on the Moon and elsewhere in the solar system. And once we have that established, I think over time that would create a forcing function for the continued improvement in spaceflight technology, and eventually we would even go beyond our solar system. I mean, to me that's a really exciting, inspiring future, and it's one to which we should aspire. I sent my plane up with Alhazen. We had to design and fabricate an antenna that exactly fit in the window of the plane. So we started off with a pizza dish, and we're able to do like a double-load antenna with a pizza dish and point it out the window to get the thing. Yeah, so we got the data came through really well, but the video was corrupted because unfortunately when you compress video, it's actually hard to uncorrupted compressed video, because in terms of lessons learned from Dragon 1, I mean, there's certainly a lot that we learned in every aspect of the vehicle, whether it's the heat shield technology, the engine, the Draco engine technology, orbital maneuvering, deorbit and try to achieve a precision re-entry path through the high velocity entry. That's quite a difficult thing. So although Dragon version 1 lands with parachutes, it actually, before the parachutes open, it actually is executing a very precise guided path with the engines firing during re-entry. Over time, we expect Dragon version 1 to be phased out, but we're going to carry both of them in parallel for at least a few years. The biggest technology challenge for Dragon version 2 was the Super Draco engine, because that's an engine that has to produce a tremendous amount of thrust and yet be very light. It's also got to throttle over a wide range. So it's got to be able to go to a very low throttle range to a very high throttle range. It's got to be able to react very quickly. So that it was quite a tricky thing to develop. One of the technologies that was really critical to development of the Super Draco engine was the ability to do 3D metal printing. So because it's quite a complex engine, and it was very difficult to form all the cooling channels and the injector head and the throttling mechanism, but being able to print very high strength advanced alloys, I think was crucial to be able to create the Super Draco engine as it is. The thing that's worth noting is that a lot of what is needed on a rocket or spacecraft is actually software. We actually hire a lot of our best software engineers out of the gaming industry. And in fact, for myself, I started off when I was a kid in terms of engineering. I wrote games. That was the thing that I did. So I think.
What's special about gaming?
Well, I think in gaming, there's a lot of smart engineering talent doing really complex things. In fact, if you think about a lot of the algorithms involved in, say, a multiplayer online game, compared to a lot of the math that's involved there, doing a docking sequence is actually relatively straightforward. In fact, I'd encourage people who are in the gaming industry to think about joining SpaceX and creating next generation spacecraft and rockets, and also probably in the future we'll create like droids on the surface of Mars and Moon to do things like an automated propellant depot and that kind of thing. You sort of need those features to have a base on Mars. Well, I think, first of all, I'd say America is probably the only place that where this would be possible, for a private company to get this far, and we've been able to attract an incredibly talented team at SpaceX. I think we've got a brilliant team of engineers and technicians that really did the design and construction of this spacecraft, and I think having that critical mass of talent is really what's enabled me, if you can call it me. It's not really me; it's just it's other people. But I think having that critical mass of technical talent is what has enabled us to get this far. Yeah, about 5 or 6 years after the start of the company, we also started getting some support from NASA, and actually in the last several years, NASA has really been crucial to our success. In fact, this is something I should have mentioned on stage, is that we really would not be where we are today without the help of NASA. That's an important acknowledgement. SpaceX has a very long-term mission. We want to just keep improving rocket technology until there's a city on Mars, and well, that could take a long time. And I think for the public markets, I suspect that is beyond their normal time horizon.
Space.com